In another video, we looked at finding the probability of A and B both happening at the same time. In this video, we're going to instead look at the probability of A or B happening, one or the other, or possibly both of them happening. We are still dealing with independent events, meaning that the probability of one of them happening doesn't impact the probability of the other. Okay, so what is the formula for doing this? It turns out that the probability of A or B is probability of A plus probability of B, and then minus the probability of A and B. That might seem kind of strange to you, so I have a diagram here that's going to help us. So I have two circles here that overlap. So A is the yellow circle, B is the blue circle, and then where they overlap, they make green. So when I calculate the probability of A, I am including the outcomes that are in that green section. When I calculate the probability of B, I am also including those outcomes that are in that green section. So everything in that green section got counted twice. That's why we have to subtract where there's an overlap. We only want to count those things one time. There is an exception to this. What if the circles don't overlap? Then we would say what we have are mutually exclusive events. There's no way that both of them could happen at the same time. In that case, the probability of A or B really is probability of A plus probability of B. Now let's take a look at a couple examples. The first one says we're going to draw a card from a standard deck. So we're drawing one card. What's the probability we get a queen or a king? Okay, so the formula said probability of a queen or a king is the probability of a queen plus the probability of a king minus the probability that the card is both a queen and a king. Hopefully that raised some red flags. There are no cards that are both a queen and a king on the same card, so these are mutually exclusive events, and we can just put a big old 0 for that. And we really just have to add up the individual probabilities, 4 out of 52 in each case, leading us to a simplified answer of 2/13. Some of you might say, well, couldn't I have just said I got 4 queens, I got 4 kings, that's a total of 8 cards, 8 out of 52, and reduce that? Yeah, you really could have. But it gets more complicated to do those sorts of things when we're dealing with a question like this. Suppose we draw one card from a standard deck, but this time we want to know what's the probability that we get a red card or a king. Okay, now there's some overlap, so it's going to be a little bit harder to do the counting. So the easier way is to use our formula, which says probability of a red plus the probability of a king minus the probability of both a red and a king at the same time. That is possible, right? We have the king of hearts and the king of diamonds. So there are 2 cards that meet both categories that would be counted twice here. So the way we would calculate this is for the red, 26 out of 52, for the kings, a 4 out of 52, and then minus that 2 out of 52 for the cards that are both. Then when we simplify our answer, we come down to 7/13. Okay, you ready for one more? If this is starting to make sense to you, go ahead and read the problem, hit pause, and then check your answer. All right, so in this problem, we have a drawer that has our socks and t-shirts. We had the 10 pair of socks, 6 which were white. We had the 7 t-shirts, 3 of which were white. And we're going to reach in randomly and grab a pair of socks and a t-shirt. We want to know what's the probability at least one of those is white. I either get white socks or a white t-shirt, or maybe both, but I get one or the other. So I'm going to apply my formula, the probability of white socks plus the probability of a white t-shirt minus the probability of getting both the white socks and t-shirt. All right, this goes back to our other video, so if you're not sure where this is coming from, go check that other one out. So the probability of white socks is 6 out of 10. For the white t-shirt, it's 3 out of the 7, minus the probability that I'm getting both of those at the same draw is 6/10 times the 3/7. Right? We had to multiply the probabilities there. And when I put all this in my calculator, I get 0.77 approximately. Now let's go ahead and grab that calculator here and I'm going to show you how I do it. Let me clear this all out and say, all right, so what am I doing? I'm going to do 6 divided by 10, and then we're going to add the 3 divided by 7, and then we're going to subtract, and I'm going to use my parentheses, the 6 divided by 10, and multiply it by the 3 divided by 7. All right, so just like that, I don't have to get in individual little steps. I'm going to put it all in the calculator at the same time, and then I'm going to hit enter, and I get my answer here. And if I don't want the decimal form, remember we have the ability to convert to a fraction, so we could give that answer as well. Let me know if you have any questions.